Hello students, today in this class we are going to understand the fundamentals of physics. Let us start with the question, what is physics first of all? Right children, physics is nothing but one of the branch of science, right? In the science we can divide into three types basically when you come to high schools level. So physics, chemistry, biology and all. So in that main important, what is the physics? Physics is nothing but for children, it is a study of nature. So why we call it as a study of nature? Because see, in the physics we can learn regarding the light, right, and regarding the sound, and we also study about the regarding the waves, how the light waves will travel, and we also study regarding the what is electric current will be coming and going, and whatever the mechanical energies will be producing, whatever the force will going to apply, so what kind of force required. So everything we're going to study in the physics. That's why whatever the natural calamities will be happening, earthquakes, tsunamis, everything we're going to find out using the physics class only. And if you're supposed to launch the rocket, so what speed it is, how much acceleration it will go, what time it will take to reach there, so everything we're going to find in the physics only. That's why we can call the subject is also called as a study of nature. And also nothing but like stars, solar, planets, like solar system, everything we're going to study in physics only. So it is also called as a study of nature. Let us study children one by one in the physics what are main important terms to understand the physics required. See how in the alphabets in required for English to understand, like that in physics some of the terminology is very important to understand the physics. So that is what my intention is today, to help you out in the basics, to build the basics in the physics. First of all, see, actually in the physics we'll concentrate on quantities. See, what does this quantities means? So there are two types of quantities we can see. There is a physical and non-physical. Non-physical quantities. See, physical quantities which can be derived, okay, or which can be like quantities means like children we can tell like how much, okay, like how many number is there. Suppose in a bag how many numbers are there, we can count and tell. And suppose in a bag, suppose cotton is filled, how much cotton is there, or what is the length of the line, what speed it is moving, that is what and all comes under length, amount, so volume, area, cupid, everything comes under the quantities. Here two physical I told, physical and non-physical. Physical means which can be, okay, measurable, which can be measurable, they are called as a physical quantity. And the quantities which cannot be measurable, which cannot be measurable. So what is the meaning can be measurable and cannot be measurable? Means measurable means which can able to find out how much. Let us imagine children, this line is given, so use your meter scale and you can tell it is 2 centimeters is there exactly, or you can tell distance between the two villages like 2 kilometers, or suppose here's on one bag of something items is given, you can tell the how many kgs it will be. So this and all quantities we can exactly measurable, so they are called as a physical quantity, like length, mass. Suppose you can see your wall clock and you tell what is the time now, around 3 o'clock. Okay, this is a wall, we can be measurable, they're called physical quantities, or measurable quantities, they're called physical quantities. And this is what we're going to concentrate in physics, we're going to study. And non-physical quantities also there, they're like happiness. So how much you feel happiness, suppose somebody given anything, so how much happiness, or your sadness, or you will get any pain, so that you cannot able to measure, right children? So this is and all what we call as a non-physical quantities which cannot be measurable, right? They are called as non-physical quantities. Examples are this. I hope this is clear children. In physics we're going to study further, it is regarding the physical quantities only. Non-physical quantities we cannot study in the physics. So now coming to the physical quantities. In physical quantities, again we can divide them into different groups. So in the physical quantities, we can mainly divide into three types. One is fundamental, supplementary, and the derived physical quantities. So different quantities we can divide actually. So before dividing this one, so based on what they can divide? So based on SI system of international system of units in the conference, or yes, Physical quantities can be divided into three types based on the SI system, like system of international system of units we can call. So according to this SI system, we already divided the quantities. So before this SI system, how the olden peoples are measuring? So actually they are following different various system of units. Okay, they are following various system of units, that is the FPS systems, FPS system, and afterwards they're following CGS system, and again they're following MKS system. So at the last they are following the SS system. This is what finally we are using nowadays. So FPS means that various system of units. System of units. Actually, in olden days, before SI system, in different countries, they are following different system of unit, that is FPS system of units, CGS system of units, and MKS system of units. So what is CGFPS? F means it is like a length factor, and this is mass factor, and this is a time factor. So length they are telling has a foot, pound, mass, and second is time. Second is same in our system, but in a CGS system there is centimeter, gram, second. Nowadays also we are using sometimes it is CGS system. And MKS system, mass, kilogram, and second. What is the disadvantage? Now also we are following meter, kilogram, and second only, but meter, kilogram, second, here only three are the fundamental units are there. But in SI system it is not like that, only three we cannot sufficient to explain entire physics. So that's why in SI system they actually given there is not only three fundamental quantities, there are seven fundamental quantities are there. So that we're going to list now, and we're going to understand definition of each. So fundamental quantity according to SI system, there are seven fundamental physical quantities. Physical quantities. So seven fundamental quantities. In that first one is length. So what is the length, children? Length is nothing but extent from one end to another end. How much extent is there? Suppose this is a 2 points are there. So how much extent is there from one end to another end? Suppose any body you can take. Suppose one pen you taken. So from one end to another end, how much extent is there? So that is what we call as a length, like 2 meters, 2 centimeters. So the SI system, the unit is also given. The unit is given by length is a quantity, and the SI system is SI unit is it is a meter, and the symbol we can write as a small m. And the next quantity is the length. Next quantity is mass. So mass, you know, amount of matter contained in a body. Suppose if you taken one cover, how much grains are there? That is nothing but a mass of that body. Mass is nothing but amount of or quantity of matter. Okay, quantity of matter in a body. Understood, children? It is nothing but what? It is the extent. So one end to another end is called the length, and similarly mass means matter contained in the body. That is nothing but the mass. So mass we can measure in terms of kilograms. Kilograms, and the unit will be small k and g. This is a kilograms. And the third quantity is time. We can measure the time, right, children? That's why it is a fundamental physical quantity. And time means suppose any event is happening. Suppose a ball is coming from here to here. That event, the extent of that event, that is what we call as a time. Okay, understood, children? The extent of the event, what we call as a time gap, or the instance where the something is happening. The instant, the situation, that is what we call as a time. And the unit we can be using the second as a unit. That is the symbol will be yes. Similarly, the fourth one we can see, we can use thermodynamic temperature. Thermodynamic temperature. So we can tell no children in if you go to hospitals and all, they can measure your body, whether body is hot or cold, and you can decide your temperature, telling that your body is very hot, 100 Fahrenheit, you have a fever. Like the temperature, you can measure nothing but it is a measure of or degree of, okay, it will measures, tell you exactly what is the hotness or coldness of a body. Okay, measure of hotness or coldness of a body we can decide using the factor called thermodynamic temperature in the physics. Okay, thermodynamic temperature, the unit is given as Kelvin. It is actually the scientist name, so we have to write it is a capital K. While writing the complete unit we can write small k, Kelvin. Next, fifth one, we can use the luminous intensity. Luminous intensity. What is this luminous intensity means? See children, in suppose if you take the sun, moon, something else, how much of light energy coming out in all directions from the sun, that is what we call as a luminous flux. Okay, in all directions how much of light energy will come, that is what we call as a luminous flux. But luminous intensity means in one direction, let us take in one solid angle, how much of energy will go per unit area. So that is what we call as a luminous intensity. Amount of light energy will come in that unit area in outwards in the three dimensional, like it will be like a r square format. So how much light energy will come out in all directions, that is luminous flux. So how much luminous flux per unit area? Okay, luminous flux per unit area, that is what we call luminous intensity. So that means amount of light energy coming out from the any luminous bodies. Luminous means which will emit their light by their own, that is what we call luminous bodies. From the luminous bodies, amount of energy, light energy come out, that is what called luminous intensity. So unit will be candela, and we can write these small letters C and D, for that the symbol. And the sixth one is amount of substance. Amount of substance. See, amount of substance, children, actually if you go for large scale, like we can see the some object, we can put on the weighing machine and can measure the mass of that object. But you imagine like atomic level, small atom, we cannot able to hold only. How can you put in a weighing machine and measure the mass of that atom, children? Or any small molecule, one drop of a water molecule you can take. See, that water molecule amount of mass of that molecule, we cannot able to measure. Very small substances in chemistry, you can some ClHCl, some substances will come. That substances we cannot able to put them in the weighing machine and measure. So very small scale, what will go, we'll see through the microscope. What will go, we'll see through the microscope and measure and count how many number of particles are there. So that number of particles is there, children, number of particles. So that is nothing but the amount of substance. For very small scale, if this mass and the amount of substance, that is the same. The amount of substance is nothing but number of particles will be present. That is actually for standard they given as a mole. One mole will be containing 24, 10 power of 24 around number of particles, and the symbol will be MOL. This is gives you the amount of particles will be present in very small amount of the substance. Okay, that is that one mole. And the last one is electric current. This is not a least but is very important form of energy what is required for our life. We completely depend on electrical energy or electric current, right children? Nowadays without current we cannot survive only, that much we define. But this is a very important form, electric current. Electric current means amount of energy, okay, around or any number of electrons or charges passing in unit area in a given time. So that is what is called as a electric current. Understood children? The flow of electrons also we can call flow of charges in a bar. In the insulator it won't flow, right? Definitely in only in the conductors, like in case of the electrical wires, you can see when you switch on the bulb will glow. How bulb is connected to switch is connected to bulb. When you switch on, the electricity will allow to flow to the bulb and their charges will be coming out. So that is what we can see, the electric current. Okay, the flow of charges in a conductor, that makes the electric current. It is indicated as ampere. Okay, actually symbol will be ampere, and you can write the unit. This is scientist name, so you must follow small letter ampere. Hope it is clear children. All the 7 fundamental quantities were definitions, the SI units and their symbol. Even we can write for this the dimensional formulas also. Dimensional formula of the mass will be, dimensional formula of the mass is M. 1 we can write dimension formula. Always we can open the box and we can write inside. And for the dimension formulas, always we can write in the box, where mass, meter, length is the starting letter of the L we can take, that is length. And for the mass we can take M, M1 or M we can write. For the time, starting letter will be T, so we can take T. And for the temperature we can take theta. This is what the use we can word the use, or we can also take Kelvin also. And candela we can write CD. This is a dimension formula. And amount of substance we can write small mol. This is a dimension formula. And electric current, some books we are following the I, and some books they're also following the A. Okay children, this is for electric current. These are the different fundamental quantities what is required in the physics. This is like a alphabets. Without the 7 fundamental quantities, we cannot do anything in the physics. Hope this clear children. The alphabets what is required to understand the physics is that the fundamental quantities are the 7. Hope this is clear children. Yes, the next is the supplementary quantities. Supplementary quantities. See, supplementary quantities is also a fundamental. They also not can be derived from any other quantities. See, fundamental quantities we cannot be derived. They will be present their own. Like supplementary also not derived, but only difference is that the supplementary quantities does not have any dimensional formula. They have no dimensional formulas for the supplementary quantities. Which are those? They are the radian. That is what we call quantity has angles. Like angle, have you know, right children? Suppose any two lines, okay, if a two rays will be meet, the initial point of two rays will be at one point, or union of two rays, okay, anything, the union of two rays, what we call as a angle. So this is what we call, in case of plane it is plane angle. Suppose in case of 3 dimensions, suppose imagine an ice cream cone or like a pyramid, where it will come actually 3-dimensional angle will come, okay, solid angle. So that is what we call solid angle. In case of 3-dimensional geometrical figure, we can take solid angle. In a 2-dimensional, in a plane, if it is limited to plane, it is not coming front, only limited to one plane. So they are called as a plane angles, or plane angle we can tell. So plane angle we can measure using the radians. See children, in your geometry box, you have a kind of protractor like this, right? So it will be starting from 0 and ending with 180 degree. Here will be 90 degree. We can measure here 10 degree angle, 20 degree, 30 degree angle. So we can able to measure the angle, that is in terms of degrees, or we can tell, and radian we can convert into degrees. But radian we can usually tell, that is in SI this is a fundamental, or in SI this is supplementary unit will be, in according to SI system it is SI unit of this supplementary quantity is radian. Similarly for solid angle it is radian. Or the symbol we can use it as a RAD, sorry, this is a radian, or we can use a symbol RAD, and here we can use SR, radian we can use. So this is what regarding the supplementary quantities. Okay, where we can use supplementary quantities in case of rigid rotators or rotatory dynamics, we're going to use this supplementary angles, or to understand regarding the astrophysics, what light will come, to understand the gravitational force, instead of r square angle it goes on increasing. So that time we're going to use the solid angles, but this don't have any dimension formula. So like dimension formula, fundamental quantities are there, for dimension formula of this is not there. Hope it is clear children. Next, last one, it is a derived quantities. Derived physical quantities. See, what else this derived physical quantities are? The quantities which can be derived from other physical quantities. Just imagine children, you need to prepare a coffee. Okay, you wanted to prepare a coffee. So what you need to add? So suppose to add milk, cup of milk, and suppose to add coffee powder, right children? And you're going to add again like water if you required, and you're going to add sugar if you required, right? So all these ingredients are like a fundamental things. If you mix all these fundamental things, then only you will get the derived thing. Derived thing has a coffee. So this derived quantity, this for coffee is what children is like some of the derived thing. So where you will get this one? By mixing all the fundamental thing by your own calculation. Similarly, okay children, similarly the derived quantities are the quantities, we'll get these quantities by what children? By actually multiplying or subtracting or dividing. What are the some operations we'll do, so that you will get the derived quantities. So we finally get the derived quantity from some supplementary quantities. Maybe you can use supplementary, or also we can use again one more derived quantities, or we can use some of the supplementary quantities also, like fundamental quantities also we can use to derive this physical quantities. So that is what we call derived physical quantities. Let us learn one by one in the derived. First derived quantity will be like mass, children. Sorry. First derived quantity will be area. Let us take it as area. So what is area? Area is nothing but a region bounded by the between the boundaries. Suppose this is one box is there. What is the region bounded in this boundaries? Okay, between this boundary. This is a one boundary line. It is looking like a rectangle where length is no, breadth you know. That time we can find the area will be you are given by length into breadth. If you find the region bounded between, that gives you the what children? Area. So here length is what children? Fundamental quantity. Breadth is a fundamental quantity, but we are deriving the area. So it is a derived physical quantity. We are getting from where? From fundamental quantities. So examples. So we can write SI unit for this. How to write SI unit? No. So length you know we can measure it in meters, and breadth is also measured in meters. So we can write it is meter square will be the SI unit. And dimension formula, how to write for this is children, see length, meter means length, how many times are there, how much power is there here, that power you have to write here. So dimension formula of area will be L2. Okay, like this we have to write. Let us take now volume. Volume is nothing but the space occupied. Suppose you've taken a 2 jars, here only so much less amount is there. Okay, how much quantity is there? Very less. Here it is occupied up to here. So now here we can take volume is less here, volume will be more here. So volume is nothing but the space occupied by the object. How much body occupied the space, that is nothing but a volume. How can you measure if it's a solid figure? Let us take a cuboid. Okay, in case of cuboid, the volume we can write length into breadth into height. So nothing but what children? If we can length, breadth, height are the fundamental. Here we can write meter into meter into meter. So we can write it as meter cube. So it is like a dimension formula. Meter means L, and we can put the square bracket, and inside you can write how much power is there. That power you can going to rise here. That is the L cube is a dimension formula of the volume. Okay. So like that we can write again volume done. Let us take density. Okay. What is the density? So you know very well children the word denser. So we are using now in day-to-day life the word denser. The forest area is more densely packed. So it means denser forest, it is dense forest. We are telling the word dense forest. So what is the meaning of dense? Suppose you take in forest unit 1 acre of the area in forest and 1 acre of the area in the land you can take normal village side. So you can see here more number of the trees will be present, right children, and here very few trees will be present. That's all. So here amount will be more if a mass is more. Okay, amount will be more. Yes, density. Density means it is denser or less denser. We are telling the word denser. In case of forest, you can see more number of the plants or trees are there. So we can tell it is more denser with the trees compared to the normal areas. Normal it is very less number of the trees will be there. Like that we can tell urban areas are more populated, right, compared to rural areas. Nowadays urban areas you can see more number of the houses, number of peoples will be more compared to rural areas. Like that. So denser means number will be more. Suppose if you take one box of cotton and if you take the same box, one more box of iron. Okay, if you take iron inside that, it will be heavy mass. Okay, number of particles will be filling more, and here what we can take, its mass is more. But here what happened, mass is very small. If a mass is small, cotton, and here mass is more, and in a given volume is same. Okay, volume is same but mass is small here, mass is more here. So when more mass is there, we can tell it is a more denser. Understood no children? Density depends upon mass and unit volume. In a given volume, more mass, more density, and more volume also. If mass of the particles, each particles is more, of number of particles will be more, so density will be more. If you take a one bread, piece of bread, if you crumpled it into a small ball, that time what happen, all particles will come closer, only this much of volume will occupy. That time what happen, volume is less means density will be increasing. Understood no? If volume is less, density will be more because it is inversely proportional. But mass is directly proportional. If mass is more, density will be more. Hope it is clear children. density given by mass by volume. So mass we can measure it kilograms. So mass is a fundamental quantity. Volume is a sum of the derived quantity. We are deriving this density from mass and volume. Volume we can write in meter cube. So dimension formula, mass means it is m, meter means it is L, but is there down. If you take it up, becomes -3, and there is no time. So we can write the dimension formula like this, and this is the SI unit. Understood, children? SI unit of density is this, and SI unit of dimension formula of density is this. Hope it is clear, children, density, right? Next, let us learn about the factor called distance, displacement, speed, velocity, acceleration, force, energy in the next class. This is also derived quantities that we're going to learn in next video. Thank you, children. Thanks for watching.